Our lesson on 6.3 is going to have you add, subtract, and multiply polynomials. Now we are also going to divide polynomials, but we're going to cover that in a couple different sections later on. So first, let's talk about adding two polynomials together. There are two methods, and there's a vertical method and there's a horizontal method. Now if you're anything like me, you're not willing to rewrite them, so basically whatever format it is given to you, that's the method you're going to be using. Now the nice thing about the vertical method is everything's lined up, so you just kind of add up the common terms that are lined up. So 3x to the third plus 1x to the third gives you 4x to the third. 2x squared plus a negative 10x squared is a negative 8x squared. Negative x plus nothing is just minus x, and then negative 7 plus 8 is a plus 1. And that's your final answer. Now the unfortunate part about the horizontal format is they're not lined up, so you have to kind of be careful who's like terms. But I will tell you mostly this is the way your problems will be written in Algebra 2. So I look for my lead term, which would be 9x to the third. There's no other x to the third, so that's just the only one. And he's gone. And then I've only got one x squared term, so I'm going to say plus 5x squared. But then I notice I have some x to the first common term, so negative 2x plus 12x gives me plus 10x. And then plus 1, and then plus a negative 4. When I combine those, it gives me a minus 3. So definitely not difficult problems, but they are easy to make really silly mistakes on. So work a little slower than normal when it's on something important like homework, quizzes, tests, or even your ACT test. Now when you're subtracting polynomials, you're much more likely to make a mistake, so really pay attention. The vertical format's nice and easy because they're lined up. 8x to the third minus 2x to the third gives us 6x to the third. Now when you go to the next terms, remember everything after these parentheses is being subtracted, so you have to remember that. So this is really negative 3x squared minus a positive 6x squared, so it's really negative 3 minus 6, which is negative 9x squared. And then again, remember you're subtracting, so negative 2x minus a negative 1 is really negative 2 plus 1, so it ends up being a negative x. And then 9 minus 1 is really a plus 8. So again, be careful and remember that anything after the negative symbol, because of the parentheses, everything's being subtracted. So 2x squared minus 3x squared gives us negative 1x squared. Those are gone. 3x minus 1x gives us plus 2x. Those are gone. And then be very careful here. 0 minus a negative 4 is really a plus 4. So while again those are easy problems, they are very easy to mess up on, so work a little slower than you normally would when you have to be really accurate. Multiplying polynomials also has a vertical and a horizontal method. What looks like an x over here is really just a multiplication symbol, so don't confuse that with an x. We're going to multiply just like you used to multiply back in first and second grade. So you're going to start with this first number and you're going to kind of multiply to everybody in the top row. So negative 3 times 4 is a negative 12. Negative 3 times the 2x is a minus 6x. Negative 3 times the negative x squared is a positive 3x squared. And then remember in second grade, you put a placeholder here while you shift it over to the next term. So x times 4 is a plus 4x. X times 2x is a plus 2x squared. And then x times negative x squared is a negative x to the third. And then remember in second grade, your teacher would have you add up your columns. That's the reason you put a placeholder, is so that your like terms were actually in the right column. So we end up with a negative x to the third plus 5x squared minus 2x and then a minus 12. And that would be our final answer. Now again, more than likely your problem will be in the horizontal format. So you really just have to think of this as a gigantic distribution problem. So first we're going to take the x and we're going to distribute him to everybody. So x times 3x squared is 3x to the third. X times a negative 2x, excuse me, is a negative 2x squared. X times a negative 4 is a minus 4x. And now we're going to do the same distribution, but this time with the negative 3. Now, I'm going to use a trick that a child taught me one day, actually. Instead of writing it in a horizontal method, every time they write down the next 3 terms, they're going to put them underneath their like term buddies. So negative 3 times 3x squared would be negative 9x squared, so he taught me, he wrote it right there. and that way he was ready to add them together later on. Negative 3 times a negative 2x is a positive 6x, and then negative 3 times a negative 4, he doesn't have a like term, so we're just going to put a plus 12 over here. So now when you add together your like terms, you end up with 3x to the third, negative 2 plus a negative 9 is a negative 11x squared, negative 4 plus 6 is a plus 2x, and then there's a plus 12 off to the side. Alright, again, not a difficult problem, but you got to be careful you don't make silly mistakes. Now when you have a problem like number 7, I have 3 binomials multiplied together. There's not a quick way to do this problem. So what we're going to have to do is we're going to have to FOIL in 2 separate problems. So what I always like to do is take the back 2 and FOIL those together first. So I'm just going to go ahead and I'm going to rewrite the x minus 1. But then I'm going to go ahead and quickly FOIL x plus 4 times x plus 3. And when I do that, I get x squared plus 7x plus 12. And now I'm ready to go ahead and distribute. So just like the last problem, I'm going to take the first term, the x, and multiply them into everybody. And I'm going to do the same thing with the negative 1. So big distribution. X times x squared is x to the third. X times 7x is plus 7x squared. X times 12 is plus 12x. And now same thing with the negative 1. So negative 1 times x squared is negative x squared. Negative 1 times 7x is a minus 7x. Negative 1 times 12 is a minus 12. And then when I go ahead and I add together my like terms, I should get x to the third, let's see, plus 6x squared plus 5x, and then a minus 12. Easy enough. Okay, now on number 8, be careful. This x minus 5 squared is in its own right another little FOIL problem. So I'm going to go ahead and FOIL that together. I'm going to keep the x plus 2, but I'm going to rewrite the x minus 5 squared as what he really is. Well, x minus 5 times x minus 5 is really an x squared minus 10x plus 25. Okay, and now I'm ready to FOIL. So multiply everybody by an x, I get x to the third minus 10x squared plus 25x. That was me distributing this x into everybody. And now we're going to do the same thing with the plus 2. So when I do that, 2 times x squared gives me a positive 2x squared. 2 times 10x, negative 10x, excuse me, gives me a negative 20x. And then 2 times 25 is a plus 50. So when I go ahead and I add together my like terms here, I get x to the third minus 8x squared plus 5x and then plus 50. Again, I cannot stress this enough. I know you have the skills to do this perfectly. You just have to be working a little more cautiously than you normally would, because they're very easy to mess up on. Now, we have a couple of special patterns that we run into quite a bit. The sum and difference of binomials, squares, and then the square of a binomial. So you just have to kind of take this with a grain of salt. You don't have to memorize these patterns. You probably already accidentally memorized one of them in our factoring lesson. I will teach you another method for squaring binomials called binomial expansion using Pascal's triangle. That'll come up later. But for now, if you just want to think about I'm squaring a binomial through the FOIL method, that's fine. So x plus 2 squared is really x plus 2 times x plus 2. And when you FOIL that, you get x squared plus 4x plus 4. So in my opinion, it's not that hard to just FOIL that problem out rather than think of some pattern that you're supposed to have memorized. Now, could you have used the pattern? Yes, and it would have been this pattern right here. So you would have said the a is the x and the b is the 2, and then kind of substituted those numbers in and made it work. But again, it might be easier for you just to FOIL it out. So same thing here for number 10. We have 3x minus 4 twice, so 3x minus 4 times 3x minus 4. 3x times 3x is 9x squared. You have a negative 12 and then another negative 12x, so that gives us a negative 24x. And then negative 4 times 4 is a positive 16. So I just decided to FOIL that or distribute that, but of course you could use the pattern. In that case, in that problem, you would have used this pattern because it was the difference of a minus b. Now for number 11, you might remember that when you multiply two conjugates together, x plus 7 and x minus 7, this FOILs really beautifully because the outer and the inner term are going to cancel out. So you're just going to end up with x squared and then minus 49. So when we are cubing a binomial, there is a pattern for that too, and here they are. Now you are welcome to memorize that pattern if you would like, and when we go to work with Pascal's triangle, I'll show you another method to do this. But since most of you are not in the memorizing mood, you might just have to FOIL this the old-fashioned way. So x plus 3 cubed is really 3 of these guys multiplied together. And remember, if we do this, you take the back two terms and you FOIL those together first. So we have x plus 3 times x squared plus 6x plus 9, and then it becomes a gigantic FOIL problem, or distribution problem. So we have x to the third plus 6x squared plus 9x, for when I distribute the x to everybody. And then when I distribute the 3, I get a plus 3x squared plus 18x and a plus 27. And then when I add up my like terms, I get x to the third plus 9x squared plus 27x plus 27. Now, of course, if you use the pattern, which we would have used this pattern right here, you would have ended up with the same polynomial answer. But two issues. First of all, you'd have to know the pattern, and then you'd have to know how to use it. So if you would like to do these problems that way on your homework, that's fine, but you're going to have to do a little bit of memorizing to get these right on the quiz. Okay, number 13. 2x minus 5 to the third power. If you would like to use the pattern, you go right ahead. If you would like to just FOIL it out the old-fashioned way, that's fine too. So if you would like to FOIL, you're just going to FOIL these back two together first. And that's going to give us 2x minus 5 times 4x squared. Let's see, it's a negative 10 with another negative 10, so it's a negative 20x in the middle. And then plus 25. And now when I go to FOIL all this together, I'm going to start by distributing the 2x. So we have 8x to the third minus 40x squared plus 50x. And then when I distribute the negative 5, I get a, let's see, negative 20x squared positive 100x and then a minus 125. So when I combine all those like terms, I get 8x to the third minus 60x squared plus 150x minus 125, which is my final answer. And again, if you wanted to use the pattern, which in that case you would have had to have used this bottom pattern here, it would have come out to the exact same answer. This problem's a little tricky to use the pattern because your A is a 2x and your B is a 5. So when you're cubing and squaring the 2x, you have to kind of think about doing that to both the 2 and the x. Alright, and then our last section, our second to last section, says from 1985 to 1995, the gross income for farm, represented by G, and the expenses, represented by E, can be modeled by these two functions. They want you to write a model for the net income. Well, just like when you work at your job, to find the net income is you take your pay and you subtract off any expenses you have, or in your case usually taxes. So what we're going to have to do is take our gross income and then subtract off the expenses. So when I do that with our polynomial, we're just going to do a little subtraction problem. So negative 0.246 t squared plus 7.88t plus 59 minus, and then I'm going to subtract off the entire expenses, so I'm going to use parentheses around it, and then you betcha I'm going to be using a calculator for this because I do not trust my brain this late at night trying to subtract. So I just got to be cautious that I remember to subtract everybody. So on my calculator, negative 0.246 minus 0.174 gives me a negative 0.22t squared. 7.88t minus 2.54t gives me a positive 5.34t. And then 159 minus 131 gives me a plus 28. So the net income can be represented by this model. And that's all they wanted, so we're done with that problem. Okay, the last problem on your notes says you're trying to raise money for your trip to Spain and you are going to sell cookies. Your revenue from selling cookies is given by the equation 2.5x. The cost for making cookies is given by the equation x plus 32. So what are we selling each cookie for? Well, you can look at that if you look at the revenue equation. Revenue means money that you're bringing in. So it's 2.5x, meaning x is the number of cookies. That must mean I'm selling these cookies for $2.50. And I can see that right there in the revenue equation. So the next question says, write a profit function. Well, the way you would find profit is you would take your revenue, the money that you're bringing in, but you have to subtract off your cost function. So for us, our revenue is 2.5x, and then if I subtract off the cost function, I need to put him in parentheses because he's a more than one term function, polynomial. And if I think about distributing the negative, my profit function ends up being 2.5x minus 1x comes out being a 1.5x. And then when I distribute that negative to the 32, I get a minus 32. So what that means is when I started, selling these cookies, there was some sort of a startup fee of $32, and I don't have enough information to know exactly what that is. Maybe it meant those were the ingredients that I had to buy, or maybe I had to pay somebody $32 to make these cookies before I started. But because I'm selling the cookies for $2.50 and it seems to cost me $1 for every cookie, I'm really only making $1.50 profit off each cookie. So the profit for selling 381 cookies, we're going to take our profit function and we're going to plug in the 381. So 1.5 times the 381 and then minus 32. So if I go ahead and do that on my calculator, I get 539.50. Okay, and that concludes our lesson on 6.3.